Hello everyone, welcome to my your programming club. Today we will be solving another daily read code problem, and the problem's name is lucky numbers in a matrix. Okay, so the according to the problem statement, you will be given a m cross n matrix of distinct integers, and you have to return all the lucky numbers in the matrix in any order. Okay, and a lucky number in a matrix is defined as this number should be minimum in its row and maximum in its column. Okay, so you have to return all the lucky numbers in the given matrix. And before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, n and m, which will be the dimensions of the matrix, will be of order 50, and each entry will be of order 10 raised to power 5. Okay, and all the elements in the matrix are distinct. So let's see how we can solve this particular problem. So let's open the board and discuss how we can solve this. So in order to solve this particular problem, what we can do is, for each row we can find minimum value. Okay, and minimum value containing column. Okay, okay, so let's say there are three rows given to you, and in those three rows there are three columns. Okay, so situation is something like this, and you are having something like 1 2 and then 3. So as you can see in the first row, 1 is the minimum, and this one should be maximum in this column, this entire column. This, if this one is maximum, then we will say that this one is a lucky number. Okay, so this is what we have to do. For each row we will be doing it, and if the minimum value column, so this was a minimum value column. If the number that we have found, this minimum value is the maximum value in the minimum value column, so let me write here, if minimum value row is maximum in minimum value column, then you can say that then it will be a, then what is it, it is minimum value will be a lucky number. Okay, so we have to make sure of this only, and we can have a list or array and add those lucky numbers into it and return it. Okay, now let's see the implementation. So let's take a fresh slide. So this is the implementation. Let's zoom in a little bit. I think this should be fine. So as we discussed, what we are doing here is, first of all, these are just couple of variables to store the dimensions of the matrix, and this is the list that we will be returning containing of lucky numbers. And we are just doing a simple traversal here, a nested traversal, visiting, first of all, for each row we are finding out the minimum value and the column having that minimum value. Okay, for each row minimum value and column having minimum value. Okay, so minimum value column and minimum row value we are interested in. Okay, so we have initialized minimum row value to a uh, value that is not within the range of the entries in the matrix, which is 10 raised to power 5. So if we take integer maximum value of an integer, then it will be outside the boundaries. That's why I have initialized it to it. And for minimum value column, you can initialize it to anything, but here I have initialized it to -1. Okay, so if your current value is less than the minimum row value, then in that case you will be updating your minimum row value. Along with that, you will be updating your minimum value column. Okay, so once you are done with all this, then you will check whether minimum value is maximum in minimum value column. Okay, so if this condition holds true, then you will say that it is a lucky number and we will simply add it. But if it is not holding true, that you are having some entry in this particular column which is more than the minimum row value, then you will say that the lucky number is minimum row value is not a lucky number, and make it a false, this variable that or this flag that we are using to check it. Okay, and yeah, then once you are done with all this, then you will be having your lucky numbers and you will be returning them. Okay, so as far as time and space complexities are concerned, here time complexity wise it will be order of rows into columns. Okay, and space complexity wise, as you must have guessed, if we ignore this lucky numbers list that we are using to give out answers, then we are not using any extra space, constant extra space. But if you want to take it into consideration, uh, even then also it will be loose upper bound can be order of n in rows into columns, but here it's pretty much constant if we are ignoring this list. So these are the time complexities, time and space complexities. And actually it will be order of rows into calls plus rows square, because this rows is being used for nested loops. So this will be the overall complexity. So once you are running a loop for columns, and then again in the nested loop you are running it for rows, so rows square it will be, or you can say rows into rows. Okay, so this will be the overall time complexity. Let me write it clearly. So order of, or let's say r is number of rows, c is number of columns, so it will be this. Okay, so I hope you are able to understand the approach, and this solution walkthrough added some value to your journey of honing your DSS skills. If you are still having any kind of doubts and any queries in general, then you may ask them in the comment section, and keep practicing more and more. I will see you in the next video. Thank you for watching.